Hello and welcome to my presentation. I am Mohammad Reza Fani Sani, a third-year PhD student in the Process and Data Science chair of RWTH University of Aachen. My main research topic is pre-processing event logs for process mining applications. In this research, Dr. Van Zels and Professor Van der Als are my supervisors. Let's briefly define the process mining domain. Process mining is a research discipline that aims to bridge the gap between traditional data science and business process management discipline. It has three main subfields that are process discovery, conformance checking, and process enhancement. In each of these subfields, the event log is a critical point, and it shows how behaviors are recorded in the reality. However, process mining algorithms have some difficulties in dealing with real large event logs. In some applications, for example, process discovery, applying algorithms directly on raw event logs result in imprecise process models. It is very often if we apply a process discovery algorithm on a real event log to have a spaghetti process model that is very complex. Sometimes a process model is too complex to be understood by a human in a normal time. Note that sometimes because the presence of infrequent behaviors in an event log, we will have imprecise process models. These behaviors could be noise or normal infrequent behavior. However, both of them are problematic for process discovery. Moreover, for other applications like prediction, the existence of outlier behavior in the event log could cause to have inaccurate results. And it is not sufficient to just keep the most frequent behaviors in the event log, because the presence of loops and concurrency in the process could result lots of infrequent behaviors. Another problem is the performance of process mining algorithms. Nowadays, by increasing the size of event logs, many of process mining algorithms are inapplicable, considering normal hardware and normal time. For example, algorithms that are using genetic miners or some conformance checking techniques are very time consuming for big real event logs. Furthermore, in some applications, it is beneficial to have a quick approximation of the final results instead of waiting for a long time to have the exact values. Of course, the approximation should be close enough to the actual results to be reliable. I should mention there are also other goals of pre-processing, for example, to integrate event logs from different sources or apply privacy issues on event logs or decrease the uncertainty in the event logs. However, in this research, the goals of pre-processing are to improve the quality and performance of process mining results. Besides, to use the pre-processing techniques, we shouldn't expect the user be completely familiar with the business of event logs. Moreover, there are many internal mechanisms to pre-process somehow event logs in some process mining algorithms, but they are very specific and customized for those algorithms. So in this work, we try to provide general solutions. In other words, if we pre-process the event logs for process discovery, it should improve the results of all process discovery algorithms, not just a specific algorithm. And we usually return a process model that could be used by other techniques. In this slide, you can see the simplified version of pre-processing techniques. Most of pre-processing techniques try to select or remove process instances in the event logs to simplify a general view. Some techniques also reduce the number of activities in the event log. There are also some approaches to generalize activities, generalized traces, using label splitting in this regard. But the goal of all these approaches is to reduce the variability of event logs, the variability of behaviors in an event logs. For example, by reducing the size of event logs, reducing the unique variants and activities. Here I want to show some results of using these approaches. In this slide, you can see the results of using different preprocessing algorithms on different event logs. All of them are real event logs. When we apply the ILP algorithm on them. When we don't use any preprocessing algorithms, that here is shows by nothing, we can see that we usually have a high fitted process model, but the precision of the process model is very low and the complexity is very high. Using different preprocessing approach, somehow we help process discovery algorithms to improve the balance between conformance metrics and quality metrics of discovered process models. For example, we see that we usually reduce the fitness value, but we increase the precision, and also we usually increase the decrease the complexity of a process model or increase the simplicity of process models. Note that in all of these cases, the required time of process discovery for preprocessed event logs is less than using the original event logs, because the size and variability of preprocessed event logs are reduced. However, if we consider the preprocessing time separated somehow, if we separate the time of preprocessing from the process discovery, we couldn't have this improvement. In some application, we can ignore the preprocessing time, but not always. Here you can see the results of performance improvement for conformance checking. The red lines here indicate using a normal alignment technique on the whole event log. We can see that many preprocessing methods are able to improve the performance. Here we consider also the preprocessing time to account. In the paper, it is mentioned that many of these preprocessing approaches are able to provide accurate approximations. That's a very good result. We faced some challenges in this research. In some applications, measuring or quantifying the quality of process mining results are not straightforward. For example, in process discovery, we have many different measures and many different ways to compute them. Also, the weights of different measures could be different. For some process mining techniques, applications, there is no measures. So for example, it is very hard to compare results of performance analysis, and it could increase actually it could be more challenging for us. Another challenge is to find how to tune the preprocessing parameters. In many cases, by changing the settings of preprocessing techniques, we will have different results. Therefore, decreasing the search space of each parameter based on the characteristics of the given event log could be beneficial. Finally, some preprocessing techniques that aim to improve quality are time-consuming. As it is explained before, in some application, we couldn't completely separate the preprocessing phase. On the other hand, some preprocessing algorithms that improve the performance reduce the quality too much. Therefore, providing a good balance is a challenging task, specifically when the user is not aware of the quality of the final result. To conclude, we aim to provide some general preprocessing solutions to improve the quality and performance of process mining algorithms. Process mining results. We aim to use different preprocessing approach at the same time, and also provide some pre-processing methods for online solutions, so they should be very fast. Thanks again for your attention. It would be great to have your feedback about this research. Moreover, if you want to discuss some ideas in this research, feel free to contact me. Stay safe and have a good time.